Hello, today we will linkage and crossing over, right? By the end of this video, you will get to know what actually linkage is and how crossing over creates recombination and how to calculate map distance in centiMorgans. For example, two genes are on the same chromosome. Do they always travel together to the next generation? For example, if capital A and B are present on the chromosome, do they always travel to the next generation? Yes, one together? What do you think? The answer is not always. They always don't travel together. Today we will crack linkage and crossing over so we can map genes in under a minute, right? Today agenda of this video is we'll cover the 5 points. First one is what is linkage. Second one is complete versus incomplete linkage. This is simply types of linkage. Third point we are going to discuss is crossing over and chiasma. Fourth point, recombination frequency. Fifth point is we'll generally like simply we'll calculate one mapping problem. So these are the five key agendas that today we are going to discuss. Okay, let's move on to the first point. What actually is linkage? Linkage generally means the tendency of genes located on the same chromosome to inherit together. It simply means if two genes are present on the chromosome, the, the tendency, they always try to move together to the next generation, right? In the next generation also, they always try to move together. For example, two friends are sitting in the classroom. For example, if they want to go to canteen, they are always, these both friends will together go to the canteen or anywhere if they are having any workers. Like same how linkage also works. These two genes will always have this tendency located on the same chromosome. These always seem to inherit together to the next generation. This is the exception of Mendel's law of independent assortment. What actually which says that when genes are on the different chromosomes or far apart on the same chromosome, when genes sit close, parental combination, like if the genes are sitting close, like if they are present close to each other, the parental combination produced more frequently means this combination will be produced more frequently, and in F2 also this may present. The frequency of this will be increasing than the any other new combination, right? So we will highlight the points here. What we have discussed with this simply genes on same chromosome inherit the together. If genes are present so close on the chromosome, like near to near, then it leads to the strong linkage. If strong linkage is there, the parental will be like parental frequency will be more compared to the recombinants. Parental, if let's see, if genes are present close on the chromosome, That means they are having the strong linkage. Strong linkage generally means parental recombination. Parental combinations will be greater compared to the recombinant thing. Now this one has been covered. Now we'll see types of linkage. We see two broad types of linkages. First one is complete linkage and incomplete linkage. Complete linkage and incomplete linkage. In complete linkage, the genes are so close that no crossing over separates them. Okay? The genes are present so close in the chromosome that here for this distance there won't be any crossing over that has been occurring. So this is very rare condition and this generally observed in Drosophila male, right? While coming to the incomplete linkage, the genes are present close to each other, but crossing over may occur occasionally which separates them. So here in incomplete linkage, recombination may occur. Recombination may occur, right? So the whole point of this is if complete linkage is present, there won't be no recombination. In incomplete linkage, there will be recombinations, right? If here we will discuss coupling and repulsion phases also. If A, B or small b. If this types of genes are there, this is called as coupling or cis phase. If capital A small b or small a capital B, this heterozygous kind of alleles are present. These are called repulsion or transphase, right? Okay. Now we will be discussing about our third topic. This is all about the complete and incomplete linkage. Now third one is crossing over and chiasma, right? What actually, first we'll discuss about the crossing over and then the chiasma. What actually happens during the crossing over means during prophase one of the meiosis, homologous pair, which homologous pair means synapses and form a tetrad. Tetrad means four, right? Non-sister chromatids can exchange chromosomes at the point called as chiasma. This crossing over produces new allele combinations for our recombinant types. For example, this is one chromosome, this is another chromosome. Crossing over this part of the chromosome, what actually happens? Okay, simply what will happen at this part, here I will extending it. See, this is the same chromosome that let me for your easy explanation I have extended here. See this part. Here, chiasma formation has took place and the exchange of this part, like this whole chromosome, till here it will be fine and this will be added. Means like this, it will be cleaved or cutted. This simply means this part of the orange chromosome, green part is adding here, and for this green, this orange part is adding here, right? Why actually it matters means it's here. Here, this homologous chromosome forms the tetrad formation. This is the tetrad formation, and then this non-sister, this and this is non-sister chromatids. Where this non-sister chromatids will exchange segments here at chiasma. Okay, already now it has been exchanged with segments. Here we can clearly see the segments have been exchanged. So why this crossing over matters means this crossing over generally creates genetic variation, and second point is due to this crossing over only we can measure our distances between genes. So, right, this is regarding the crossing over in fasting formation. Welcome, completed. Now next we will discuss about what actually recombination frequency and magnitude. Right? Generally tells us how often recombinants appear among the offspring. Okay. The formula for recombination frequency is recombination frequency is always limited in percentage. Number of recombinant offspring divided by total offspring into 100. So, by definition, we can say 1% of recombination frequency is equals to 1 centimorgan. Always remember one point while writing the centimorgan. The C will be in centimorgan, C will be small letter, and M will be caps, right? So, simply we can say recombination percentage is equal to recombinants by total into 100. 1% is equals to 1 centimorgan. And here one for small distances, for example, less than 20% of recombination frequency, map unit works well. As distance between the two genes get larger, the recombination, like multiple crossing overs can take place between this place. For example, if distance between two genes is 5 centimorgans, then very less chance of crossing over, right? Till 20 centimorgans also, it will be fine. But if the distance between two genes is increasing, which is more than 20 centimorgans, then the chance of crossing over is increasing, will be more, right? So if the more the distance, the more like multiple crossing over can be occurring, which helps in producing more recombinants, right, than the parental types. So the observed recombination frequency underestimates the true distance. Okay, this large distance, which leads to double crossover, which reduces observed recombination frequency, right? Now fifth one is we said like we'll discuss one example, right? Mapping problem. Now we'll discuss example test cross. For example, a heterozygous capsule. Wait, for easy understanding. So these both are parents, homozygous parents, and these are the F1 possible F1 combinations are recombinant F1. So if A heterozygote AB or AB is crossed with small ab means F1 like parent of the F1 is crossing with homozygous recessive parent. For example, we got 1,000 offspring. Okay, if the frequency of this 1,000 offspring, how it will be means small b, capital A, small a, capital B. These two are parental combinations. These are recombinants, right? If capital AB is 460, if this is 420, these are 60 each. Total will be 1,000, right? So recombination frequency, what actually formula is number of recombinant offspring by total number of offspring into 100. As these both are parents, these both are recombinants. So 60 plus 60 divided by total. Total means 1000 into 100. Two zeros will be cancelled. So here it will be 120 divided by 10. 0 will be cancelled. So it will be 12, 20. So it will be 12% of recombination frequency. Recombination frequency is equal to 12%. When we convert this 12% into centiMorgan, 1% of recombination frequency is equal to 1 centiMorgan, right? So 12% will be 12 centiMorgan distance, right? So here this is the thing how to calculate the distance between the two genes. Okay, because the heterozygous is in the coupling phase means both are same. So these both are the parental type and these both are the recombinant type. Okay, if all the four classes are equal means if all these four numbers are equal, for example 250 each, then the genes are assorted independently and likely on the different chromosomes. So for example, if all are in the same ratio, which means 250, then they are all independently assorting and they are likely to be on the different chromosomes. Or if they are present on the same chromosome, then they may be far from each other. Okay. The maximum recombination frequency is 50%. Beyond that, you can never tell if genes are on different chromosomes are very far apart on the same chromosome. For long distances, 3 point mapping will be done. And in this 3 point mapping, these accounts double crossing over and concepts like interference. Okay. So here the two main points you have to remember. Recombination will be frequency will be always less than or equal to 50%, and double crossing over reduces the observed double crossing over reduces the observed recombination frequency, right? So we will be recapping what actually happened. So if the linked genes are present on the same chromosome, the crossing over can separate them. Means, for example, A, B, if crossing over has occurred in this place, A will be 1 and B will be 1. So if linked genes are on the same chromosome, crossing over can separate them, and recombination frequencies will give the distance in centimorgan. In our case, it is 12 centimorgan. So linked genes gives us the recombination frequencies, which is centiMorgans. So the distance between A to B is 12 centiMorgans. Now we will discuss three MCQs. Okay. First I will ask all the three questions. You just pause the video and choose one and then you can answer. Right? First question is crossing over occurs in which meiotic state? Second question is in a test cross, parental classes greatly exceed recombinant. What does this suggest? I will come into the third question. Recombination frequency between A and B is 5%. Then what is map distance? Here are the three questions. We just pause the video and think. Now I'm going to say the answer. First question is crossing over occurs in which stage of which meiotic state? The answer is pro prophase one, right? In prophase one, chiasma formation will be take place and tetrad will be present. And this tetrad is like this one will be observed in diplotin state. Okay, but crossing over occurs in prophase one, right? In a test cross, parental classes, second question, parental classes greatly exceed recombinations. If the parental one is more than the recombinations, what is does this suggest? Means parental is more than the recombination. Then it means linkage is two. For example, parental genes is more means AB in the parent. In F1 also AB is present at the same. In F2 also AB is present at the same place, right? What does this mean? It means linkage is present between these two and incomplete crossing over. There is no crossing over. It means very less. If there is no or very less amount of crossing over is present between the two genes, right? Well, coming to the third question, if recombination frequency between A and B is 5 distance, what 5%, what will be the map distance? Map distance will be 5 centiMorgans because 1% of recombination frequency is equal to 1 centiMorgan. Okay, if this is cleared it up, subscribe to BreedCraft by Harsha. Next, we will be using 3-point test cross to map gene order and detect double crossing over. Drop your doubts in the comment section. Thank you.